The battery is the primary source of electrical energy in the automotive vehicle. It's used to power the starter motor, lights, and ignition system when the engine isn't running. So, it's fair to say that the battery is the heart of the electrical system, and without a properly operating battery, faults can start to appear. These are usually in the form of communication issues between modules, battery-related fault codes, and the big one, a no-start condition. So for these reasons alone, it's crucial that we have a sound knowledge of what's inside the battery and how it all works. Cells make up the core of the battery. So let's start by looking at a simple cell and its operation. A single cell can be constructed using a positive and negative plate arrangement. The positive plate material is made from lead peroxide, while the negative plate is constructed from sponge lead. These two dissimilar metals on their own don't produce any electricity, but submerge the two in a container filled with 60% water and 40% sulfuric acid and a chemical reaction takes place. The chemical reaction within the electrolyte solution causes the free electrons to be stripped from the positive plate and forced onto the negative plate. This means there will be a surplus of electrons on the negative plate. Because of the deficiency on the positive plate, there is a strong attraction between the negative and positive material. Whenever the plates are submerged in the electrolyte, their chemical properties will prevent the reverse flow of electrons. The only way they can return to the positive is through a conductive circuit, such as this conductor and light. Now that the circuit is complete, an electrical pathway is formed. The electrons will flow through this circuit until both plates are balanced, or there is no potential difference across the cell. So the battery is now flat. Be aware that current always flows from the negative terminal in the circuit. To charge the cell, a higher electrical pressure or voltage is required to force the free electrons from the positive plate back to the negative plate, once again creating a surplus of electrons at the negative terminal. Electrolyte is a conductive solution that causes a chemical reaction between two dissimilar metals. The electrolyte in a lead-flooded battery may be in the form of a gel or liquid. Electrolyte is a mixture of around 40% sulfuric acid and 60% water. That gives a specific gravity of around 1.270 in a charged cell. This means the electrolyte is now 1.27 times as dense as water. But what happens to the electrolyte when the battery is discharging? During this phase, the electrolyte's composition will be altered with an increase in H2O and a reduction in sulfuric acid. As a chemical reaction occurs, its specific gravity decreases. Once an electrical pressure greater than the cell is applied to the circuit, the chemical reaction is reversed. The electrolyte density increases due to the reformation of sulfuric acid. The free electrons are once again stripped from the positive and deposited onto the negative plate, with the cell-specific gravity returning to 1.270. Lead-flooded battery cells are made from a combination of sponge lead for the negative and lead peroxide for the positive. They are separated by a permeable non-conductive material such as polythene or glass fibre to prevent the two materials shorting. Each plate is constructed with a lattice grid design, featuring low internal resistance and vibrational strength. The number of plates and the size of the plates relates to the battery's total storage capacity and overall battery rating. A single cell may contain up to 13 plates, with 7 of these being negative and 6 positive. These are arranged to produce a total of 2.2 volts. All the corresponding positive and negative plates within the cell are connected respectively. They are then joined to the rest of the cells over or through the partition to the positive and negative straps. Depending on the battery's application, this will determine the size and number of plates to produce the required battery rating. For a 6-volt battery, there are only 3 cells connected in series, while a total of 6 cells will produce a 12-volt battery. Small capacity engines, or motorbikes, tend to use smaller batteries. This is achieved by reducing the size and number of the plates. Even though we have reduced the number of plates and their size, each cell is still capable of generating 2.2 volts, equating to a total open circuit voltage of 13.2 volts. Whereas a diesel or light truck battery will use more plates per cell with an increase in thickness and surface area. Using this size battery supplies more current for the additional cranking load. So, what is a battery rating? This denotes what conditions the battery has been designed to operate under. This information or rating is usually stamped or printed on the battery, but can be found in the technical specifications for that vehicle. A CCA or cold cranking ampere rating is obtained when a new battery can deliver a specified current for 30 seconds at minus 17 degrees Celsius before its open circuit voltage drops to 7 volts. High CCA ratings are obtained using a greater number of plates per cell and larger plate surfaces. Never fit a battery with a lower CCA rating than specified. A reserve capacity or RC rating is the length of time measured in minutes the battery can supply a constant 25 amps before dropping below 10.7 volts. So if we have a 12 volt battery with an RC of 120, this means that it can be discharged for 120 minutes at a temperature of 26 degrees Celsius. So in the event the charging system fails, we're still able to run the vehicle for a few extra minutes to limp the vehicle off the road. Amp hour, or AH, represents the amount of current a fully charged battery can supply for 20 hours until the open circuit voltage goes below 10 volts. This means a 100 amp hour battery is capable of supplying 5 amps for 20 hours before the open circuit voltage reaches a critical level. Lead flooded batteries have been the main choice for OEMs due to their low cost and simple construction. However, this trend is changing due to higher electrical demand and maintenance-free designs. In this type of battery, calcium is used in the construction of the plates. This offers a reduced internal resistance, resulting in a higher current flow, with the benefit of a reduced rate of discharge, minimal gassing during recharge, and corrosion resistance. A calcium flooded battery can be identified via the CA marking on the case. When recharging a calcium battery, the correct charger needs to be used to prevent damage to the cells. An AGM or absorbed glass mat battery works similar to a lead flooded type, but with the electrolyte held in a fiberglass woven mat. The positive and negative plates are attached to the mat, providing a larger surface area for the electrons to flow. The advantages of a sealed maintenance-free AGM battery include lower internal resistance, higher current outputs, resilience to vibration, long service life, produces minimal gas while charging, and they can be mounted on their side as they are spill resistant. AGM batteries can be constructed with their plates in a spiral design. This increases the surface area, allowing for an extended discharge time. Gel batteries contain a silica gel that holds the electrolyte in suspension. It allows the electrons to move freely, but won't spill if ruptured. Like the AGM, when placing a gel battery on charge, ensure the right charger is used. Gel batteries need to be charged at a slower rate. Deep cycle batteries are designed to discharge at low current over a long period of time, whereas a starting battery is used for burst current, such as cranking the engine where a higher output is needed for a short time. Deep cycle batteries can be either gel, AGM or flooded. These batteries will use larger and thicker plates to cope with the repeated discharge and recharge cycles. After examining the operation of a lead acid battery, we now have a better idea of what signs to look for when chasing a power-related fault. Recharge your knowledge and keep an eye out for more training on battery charging, operation and diagnosis. Thanks for watching. See you soon.